everyone, it's Catherine here and thank you for joining me for today's final training session on measurements. We are going to be looking at measurements in upper key stage 2. So let's start by looking at year 5. In year 5, children will be expected to convert between metric units of measurement as well as solving problems including decimal measures. So we'll be looking at calculating the perimeter and area of shapes, estimating the volume of 3D shapes and capacities of containers, as well as using some imperial units such as inches, pounds and pints. So let's start off by looking at metric and imperial measurements. Now it's interesting to give children a bit of background behind this. And the imperial measurements were used up to a point and then they were replaced by metric measurements. However, in some situations, some circumstances, imperial measurements are still used. Now it's interesting if we look at the conversion chart on here, a lot of it is about or just over. So we have to explain to children there is no direct equivalent or conversion. So for example, 1 inch is about 2.5 centimetres. Or we have 1 mile is just over 1.5 kilometres. A gallon is about 4.5 litres. So it's important that we use this to help children remember the conversions. So we're looking now at converting measures. So we're going to be converting length, mass and volume. So in problems in using grams and kilograms, we need to make sure that children, for example, are confident in converting, same in capacity and same in length. Now this is something that was looked at in year 3 and 4, but it's reaffirming this and building upon this in year 5. So looking at perimeter and area. So it's measuring the perimeter. We know that it's the outside of a shape. And if it's of a rectangle, we know that we can measure the length, the width, the length and the width. Or we can begin to use the simple formula of length plus width multiplied by 2. Measuring the perimeter of regular shapes, we simply need to measure the length of each side, or we can measure the length of one side and multiply it by the number of sides. Now measuring irregular shapes, we'll be looking at the length of each side and adding them together. I'm just going to get my pointer out on here. So if we just look over here at calculating perimeter, so we need to be calculating the missing sides of this rectilinear shape. And we can do this by looking at the sides that are already there. So we want to know the perimeter of this side. So we need to know what the length of this missing side is. And we can see that this part plus this part would equal to this. So if this is 4 centimetres, the total is 8. We know that 8 subtract by 4 would give us this missing side being 4 centimetres. And the same principle applies on here. So we can see that the length of this missing side is 2 centimetres plus 7 centimetres. So the length of this missing side is 9 centimetres. So then all we need to do is add all the sides, including the missing sides, together to get our total perimeter. So looking now at area. So looking at areas of rectangles, we can look at the areas of rectangle on a grid, whereas previously we would have counted the different squares within there. It's something we can still do. Or we can multiply the length by the width. So we can see that the length on here is 6 squares multiplied by 3 squares, which gives us 18 squares in total. Looking at the area of a rectangle, we use the same principle, the length multiplied by the width. Now when we're looking in the middle part of the area of compound shapes, we need to divide the shape into 2 rectangles or more with known dimensions. So looking on here, we've split this into 2 rectangles. Rectangle A is 7 centimetres multiplied by 4. Rectangle B, 5 centimetres multiplied by 5, which gives us the total of 53 centimetres squared. Now it's important that when we are measuring area, we put the squared at the end. Now looking at areas of irregular shapes, for example, this is a problem that we might see where it's finding the area of the land or the area of the lake. We need to find the number of whole and part squares. So the whole squares on there is 10, the part squares is 22. So we estimate the area by having the whole squares plus half of the part squares, imagining that each part is worth half. So we can estimate that there is 10 centimetres squared plus 11 centimetres squared equals 21 centimetres squared. Now that's just one way that you can use it, and it's an effective way. So we're looking at volume and capacity. So we have used the language volume and capacity in earlier year groups, but we've said that the language can be used interchangeably. Now in year 5, it's really important that we're using this vocabulary accurately. So volume is the amount of space occupied by the 3D shape. It's measured in cubed units, for example, centimetres cubed. And capacity is the amount a container can hold. And capacity is in metric units such as litres or imperial units such as pints. So if we look on here, look at this example, looking at the volume of cubes and cuboids. So we can calculate the volume of a cube and a cuboid by first calculating the area of one face and multiplying it by the area of its depth, so another face. So if I'll just get my pointer on here. So we can see that the area is here, it's 2 multiplied by 2, and the depth is 2 multiplied by 2. So we can see that the cross section of one face is this one, the depth is this one. So with 4 centimetres by 2 centimetres, the volume is 8 centimetres. And the same method applies when we are looking at cuboids. Now moving on to year 6. So in year 6, children will be able to solve problems by calculating and converting measurements to decimal places, including miles and kilometres. So this will also include looking at areas of shapes including rectangles and parallelograms, volumes of cubes and cuboids, as well as knowing and using simple formulae to work out areas and volumes of some shapes. Now we have touched upon using the simple formulae. We'll be exploring this in more detail. So again, converting and calculating measurements is really important that children know the multiplication and division process here. So in the maths, we've included that 1 tonne is 1,000 kilograms, and we know that 1 kilogram is worth 1,000 grams. So it's important that every time we step up the amount of mass that we are looking at, we reaffirm the multiplication and division to convert between the two. And if you look down the left, there's lots and lots of key vocabulary in there. So mass, gram, milliliter, kilometre, foot, inch, ounce, gallon, and all this key vocabulary that we'll be using in our lessons. Continuing to look at converting measurements. So we're looking at miles to kilometres. So we can see that we know that when we look at the length of a road, it can be in miles or in kilometres, and the rough equivalence is that 5 miles is roughly 8 kilometres. It's approximately equal to. So when we're converting between miles and kilometres, if we want to convert miles to kilometres, we divide by 5, multiply by 8, and kilometres to miles, we do the reverse, the inverse, we divide by 8, multiply by 5. And again, looking at time, so we know that the different values, whether a week 7 days, an hour is 60 minutes, for example, and it's making sure that we're really solid on that key knowledge, so when we're looking at converting problems with using that language. Now we're looking again at imperial and metric measurements here, so we need to know that some things are measured and can be measured using imperial units. So a really easy example the children will be familiar with is someone's height is in feet and inches. And we know that a person's mass might be in stones, and we talk about things like we buy milk in pints. And it's important that we children know that we can use these interchangeably, and we sometimes use imperial over metric. And again, it's looking at converting between them. So previously we were talking about them being roughly equal to or approximately equal to. Now we're looking at converting between metric and imperial. So we know that 2.5 centimetres is equivalent to about an inch. So to convert between those, centimetres to inches, we divide by 2.5. Inches to centimetres, we do the inverse, multiply by 2.5. And the same for litres and gallons and kilograms and pounds, ensuring that we understand what the different values are and how to convert between. These graphics are really useful to have jotted down, and I always have a draw a little diagram of them on the board to remind myself and to remind the children of how to convert. So now looking at perimeter. Now we have looked at perimeter before and we know that this is the total outside measurement. So we can add the length to the width to the length to the width, or we can use the simple formulae of doing the length plus the width multiplying by 2. So if we quickly look at this example on here, we've got the length here is 6 centimetres and the width here is 2 centimetres. So we can do length plus width gives us 8 and multiply it by 2 because there are 2 of them. Okay, so rather than doing 6 add 2 add 6 add 2, we can simply do 6 add 2 multiplied by 2. Now it's important that we show that shapes with the same area can have different perimeter, and shapes with the same perimeter can have different areas. So it's important that when we're asked to work out perimeter and area, it needs to be done for each individual shape. So looking at area, we have looked at area previously, but now we're going to be looking at area of parallelograms and the area of triangles. Now when we're looking at an area of a parallelogram, we simply look at it as if it was a rectangle. So we would measure the base, along the bottom here is 12, and we measure the perpendicular height, which is the height from the base to the top at a perpendicular line. Excuse my not very straight line on there. So all we need to simply do is we measure the length of the base, which is here is 12, measure the height, perpendicular height there, which is 6. So to work out the area of the parallelogram, it is 12 multiplied by 6. And the same for a triangle. So when we're looking at the area of a triangle, we want to know the area. We work out the length of the base, which is 8. We measure the perpendicular height, which there is 3. But then because if we were to do 8 multiplied by 3, it would give us the area of a full rectangle. We don't want that. We need to divide it by 2. So it's base times height, perpendicular height, divided by 2. And it's the same for whichever type of rectangle whichever type of triangle we use. It would be base multiplied by perpendicular height divided by 2. So all we need to do is remember those simple formulae, and that will help us work out the areas. Looking a little bit more detail at volumes, we did look at volume previously. So looking at volume of cubes and cuboids. So we calculate the area of the cross section of one base, and then we multiply it by its depth. So it's 4 centimetres, it's 2 times 2, multiplied by the depth, which is 2, so the volume is 8. Same on the rectangle here, but when it comes to slightly trickier shapes like this, we could count the simple cubes. So here, if they are centimetre cubes, this is 1 centimetre cube, and for example in the middle graphic we can count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can see that this gives us 11 centimetres cubed. And the same for here if we wanted to. Now it's really important that we begin to do this practically by having cubes in front of us making different shapes, and then we move on to the pictorial version. And again, reminder, make sure when we're using volume we put the unit and cubed to identify that it's volume. So looking at the area of formulae and volume, so we know that the formula for area is length multiplied by width. And when we're looking at the volume of cuboid, it'll be length multiplied by width multiplied by height. So it's important that we just multiply it by height and that we include volume. We use the centimetres 3 if we're measuring in centimetres, metres cubed, etc. So thank you very much for listening to today's training session on Upper Key Stage 2 measurement. I hope you found it incredibly useful. As always, please remember to complete the form at the end.